Please be seated, ladies and gentlemen. On behalf of the President and the First Lady, it is my pleasure and honor to welcome all of you to the White House. I'm going to present the President in just a moment. Before doing so, on his behalf, I would like to acknowledge the distinguished guests who are present. I will formally introduce our panel of Nobel laureates and university scientists in just a moment. I want to acknowledge members of the President's Cabinet who are here: Administrator of the EPA, Carol Browner, Secretary of Commerce, Bill Daley, Secretary of Labor, Alexis Herman, Secretary of Energy, Federico Pena, Undersecretary of the Treasury, Larry Summers, Director of the Federal Emergency Management Agency, James Lee Witt, Chair of the Council on Environmental Quality, Katie McGinty, the President's Science Advisor, Dr. Jack Gibbons, and other distinguished guests who are present. We meet today to discuss the future of our planet and the realities of global climate disruption. I want to acknowledge one other person who's in the room somewhere, and I haven't had a chance to see him yet, but Charles David Keeling is here. And Dr. Keeling, thank you very much for joining us. And he was responsible, along with one other, in measuring carbon dioxide in the atmosphere for the very first time back in the late 1950s. And my own introduction to this issue came about as a direct result of the measurements which showed the annual cycle of carbon dioxide and the steadily increasing peaks of concentrations of carbon dioxide, and now, of course, we know other greenhouse gases as well that resulted from those measurements. Later, when I came to the Congress quite a few years after that, in holding hearings, I saw that those concentrations had increased dramatically, and of course all around the world scientists were studying it intensively, and now we will soon hear from these scientists about what the world's scientific conclusion is about what this means for increased droughts and floods, dramatic changes in the distribution of forests and croplands, and all of this gives rise to great concern that we are committing future generations to a planet that is altered in profound ways that can cause great harm to future generations. This administration has always worked on a simple principle when addressing problems of a scientific and technical nature, and that principle is science must inform policy decisions. Scientists are by nature a cautious group, but the world's scientific community is telling us in many ways that they believe that we as a civilization are disrupting the balance of the world's climate. In the words of the 2,000 scientists who participated in the Intergovernmental Panel on Climate Change, and I quote, "There is a discernible human influence on global climate." More than 2,600 scientists have signed a letter about global climatic disruption, which we'll be hearing more about in just a few minutes. Today we hear about the concerns of scientists. They speak as eminent experts and as U.S. citizens who care about the future of this planet. Each has a resume far too long to recount, but let me briefly introduce those who are with us today. Dr. Sherry Rowland won the 1995 Nobel Prize for Chemistry for his pioneering research in atmospheric chemistry, explaining the destruction of the stratospheric ozone layer. He is also a professor at the University of California at Irvine and an official with the National Academy of Sciences. Dr. Mario Molina shares the 1995 Nobel Prize with Sherry Rowland. He is the Lee and Geraldine Martin Professor of Environmental Science at MIT. Dr. James Lubchenco is an eminent ecologist, past president of the American Association for the Advancement of Science, very active with the AAAS, and also past president of the Ecological Society of America. She is currently the Wayne and Gladys Valley Professor of Marine Biology and a distinguished professor of zoology at Oregon State University. Dr. Stephen Schneider is a climate scientist and professor at Stanford University, recipient of a MacArthur Fellowship, and winner of the American Association for the Advancement of Science's Westinghouse Award for Public Understanding of Science and Technology. Dr. Bob Shope has devoted his professional life to the study of viruses carried by biting insects. He is currently a professor in the departments of pathology and microbiology and immunology at the University of Texas. Dr. Henry Kendall won the Nobel Prize for Physics in 1990. He is chairman of the board of the Union of Concerned Scientists and the J.A. Stratton Professor of Physics at the Massachusetts Institute of Technology. And John Holdren is an expert on energy and environmental science and delivered the Nobel Peace Prize acceptance lecture on behalf of the Pugwash conferences. He is currently the director of the program on science, technology, and public policy at the John F. Kennedy School of Government and professor of environmental science and public policy in the Department of Earth and Planetary Sciences at Harvard. And now I would like to introduce the person who is leading our country and the world toward a recognition of what must be done to deal with this issue. It is my honor, ladies and gentlemen, to present the President of the United States, President Bill Clinton.
Thank you. Thank you very much. Thank you. Thank you. Thank you very much. Thank you. Thank you. Ladies and gentlemen, first let me thank you for being here. Members of the administration and concerned members of the public, the scientists and other experts that are here. I would also like to say a special word of thanks to the Vice President. In one of our earliest meetings together, we meet once a week and have lunch, he went over the whole history of greenhouse gas emissions and climatic change. And I became convinced, first that he was convinced that something was wrong. Then I became convinced that something was wrong. And it's been a great help to me, and I believe to the people of the United States, to have him in the position that he's in, not only with the convictions that he has, but with the knowledge that he has. And I'm very grateful to him for what he has done to help me come to grips with this issue. To me, we have to see this whole issue of climate change in terms of our deepest obligations to future generations. I have spent most of my time in the last 4.5 years trying to prepare the American people for a new century and a new millennium. It is also very important that we protect the earth for that new millennium, to make sure that people will be able to take advantage of all the things we are trying to do, the opportunities we are trying to create, the problems we are trying to solve. It is obvious that we cannot fulfill our responsibilities to future generations unless we deal responsibly with the challenge of climate change. Whenever the security of our country has been threatened, we have led the world to a better resolution. That is what is at stake here, and the scientists have come here to explain why. As the Vice President said, the overwhelming balance of evidence and scientific opinion is that it is no longer a theory but now a fact, that global warming is for real. The world's scientists believe that if we don't cut our emissions of greenhouse gases, we will disrupt the global climate. In fact, there is ample evidence that human activities are already disrupting the global climate, and that if we stay on our current course, the average global temperatures may rise 2 to 6 degrees Fahrenheit during the next century. To put that in some context, the difference in average temperature between the last ice age, which was 10 to 12,000 years ago, and today is about 9 degrees Fahrenheit. So we could have 2/3 of that change in 100 years, unless we do something. If we fail to act, scientists expect that our seas will rise 1 to 3 feet, and thousands of square miles here in the United States of Florida, Louisiana, and other coastal areas will be flooded. Infectious diseases will spread to new regions. Severe heat waves will claim lives. Agriculture will suffer. Severe droughts and floods will be more common. These are the things that are reasonably predictable. In the face of this, the United States must confront a challenge that in some ways is the most difficult of all democracy's challenges to face. That is, we have evidence, we see the train coming, but most ordinary Americans in their day-to-day lives can't hear the whistle blowing. They have no, unless they have lived in a place where they have experienced severe and unusual and completely atypical weather disruptions in the last 5 years or so, the degree of the challenge is inconsistent with the actual perceived experience of most ordinary Americans. And this is true indeed throughout the world. And that presents us our challenge. A democracy is premised on the proposition that if the American people, or any people in any democracy, know what the facts are and believe them, way more than half the time they will do the right thing. And so what we are doing today is beginning a process in which we ask the American people to listen to the evidence, to measure it against their own experience, but not to discount the weight of scientific authority if their own experience does not yet confirm what the overwhelming percentage of scientists believe to be fact today. This is a great exercise and a great test for our democracy. I do want to say that I am convinced that when the nations of the world meet in Kyoto, Japan in December on this issue, the United States has got to be committed to realistic and binding limits on our emissions of greenhouse gases. Between now and then, we have to work with the American people to get them to share that commitment. We have to emphasize flexible market-based approaches. We have to embrace research and development efforts and technology that will help us to improve the economy while improve the environment while permitting our economy to grow. We have to ask all nations, both industrial and developing, to participate in this process. But if we do this together, we can diffuse this threat, and we can make the 21st century what it ought to be, not only for our children, but for all the children of the world. I believe the science demands that we face this challenge now. I'm positive that we owe it to our children, and I hope that we can find the wisdom and the skill to do democracy's work in the next few months to build the consensus necessary to actually make action as opposed to rhetoric possible. And for all of you, for your commitment to that, I thank you. And now I'd like to ask Dr. Rowland to be the first of our distinguished scientists to lead off. Doctor?
Global climatic change is underway. Carbon dioxide from the combustion of coal, oil, and natural gas has risen by 15% in the atmosphere since 1958. Methane, some of which is emitted from cattle and rice paddies, has risen by 16% since 1978. The air now holds 4 times as much of the chlorofluorocarbons, or CFCs, as it did 25 years ago. The amount of ozone in the stratosphere over the United States is 6 to 10% lower than it was in the 1960s. Many other changes are occurring as well. The global average surface temperature has risen about 1 degree Fahrenheit during the past century, and sea level has risen from 4 to 10 inches. Land use patterns have been greatly altered as forests are burned for use as agricultural land. Many of the biological species formerly in these forests are disappearing. The geographical ranges of tropical diseases are moving northward. Human activities are the chief cause of many of these changes. During the 20th century, the developed countries have changed from the agricultural societies of 1900 into the highly industrialized urban environments of the present. Great forward progress has occurred in the comfort and well-being of significant segments of the global population, although not for all. Enormous strides have been made in health. Death rates are lower. Lifespans are much longer. The last century has also seen a tremendous growth in the global population from about 1.5 billion in 1900 to 6 billion in the year 2000 and 8 billion in the year 2025. Much of the progress and affluence has resulted from the substitution of non-living sources of energy for human and animal energies, the availability of engines, of electricity. Most of this energy comes from the burning of coal, gas, and oil. These energies bring with them environmental consequences: carbon dioxide from the fossil fuels, the radioactivity of nuclear waste. In Japan in 1959, I encountered bullock carts on the road to a nuclear research center. In China in 1980, humans propelled wheelbarrows to move dirt from road construction sites. In contrast, the city of Shanghai alone now has 20,000 major construction projects going simultaneously, and much of the world is moving as fast as possible into a more affluent, energy-intensive era. This combination of a rapidly growing world population with an increase in per capita use of energy carries with it great pressures on the environment and on the atmosphere. Because the winds circle the Earth within a few weeks, greenhouse gases emitted from each country quickly become a global problem requiring a global solution. Our earlier experience in dealing with the destruction of stratospheric ozone by the CFCs has taught us that humans can collectively interfere with natural processes on a global scale. Further, despite the immense amount already known about the atmosphere and the oceans, these are complicated systems with uncertainties going in both directions. Surprises can happen. Witness the devastating losses of ozone over Antarctica every spring. However, the United Nations Montreal Protocol, which is now successfully controlling the emissions of CFCs into the atmosphere, demonstrates that the nations of the world can agree to act when it's for the mutual benefit of all. During the 1990s, these countries have called upon the world's scientists to evaluate the question of global warming from the accumulation of greenhouse gases. In response, the authoritative IPCC has estimated a probable increase in global surface air temperature of about 3.5 degrees Fahrenheit by the year 2100, but with a possible range from 2 to 6.5 degrees Fahrenheit. They further stated, as you heard from the Vice President, that the balance of evidence suggests a discernible human influence on global climate, and they warned that the average rate of warming will probably be greater than any experienced in the past 10,000 years. Much of the variations in outcomes depends upon what the countries of the world do to control the emissions of carbon dioxide and other greenhouse gases in the intervening years. More than 2,600 scientists have now signed this scientist statement on global climatic disruption, in which, as scientists and as concerned citizens, we ask that the United States demonstrate strong leadership in the global effort with a firm proposal for reducing U.S. emissions of greenhouse gases.
Thank you.
Mr. President, I would like to ask a question. The scientist's statement uses the term disruption and uses the word irreversible. Those are strong words for scientists who, as I mentioned, are by nature cautious. How do the risks that we face from global warming compare to the risks from the destruction of the stratospheric ozone layer that you and Dr. Molina described several years ago?
Both of these are very serious problems for the environment. In the case of the CFCs, these were gases that were manufactured by about 20 companies globally, and all of them science-based. And the uses were almost entirely in affluent aspects of society. In the case of the fossil fuels, everybody uses energy from fossil fuels nearly every day in every activity that they do. So it's a global problem that requires actions both by the rich countries and by the poor countries. We need strong leadership from countries such as ours, which have the powerful science and technology base with which we can try to solve these problems. We can do it, but we have to have the commitment.
Well, thank you very much. Mr. President, I'd like to now ask, with your permission, I'd like to ask Dr. Mario Molina to give us an overview of the science of climate change. And to set this up for you, Dr. Molina, I just wanted to say that one of the most compelling pieces of evidence for many people is the record of climate over a long period of time, 160,000 years, that is taken from the ice core in Antarctica and also in Greenland. And as others here can explain better than I, they measure the atmosphere in these bubbles trapped in the ice, and each year is easy to record, and they pull out a very accurate record of temperature and carbon dioxide concentration. Why don't you take it from there, Dr. Molina, and correct any mistakes I made along the way there.
I'll be pleased to do that, Mr. Vice President. First of all, let me just summarize that the greenhouse effect is the name of a process which affects the heat balance of our planet. Our Earth receives energy from the sun, which passes relatively freely through the atmosphere, but the energy that the Earth emits to outer space is actually trapped. It's emitted mostly in the form of infrared radiation, and there are certain gases in the Earth's atmosphere that trap some of this radiation, affecting this heat balance. One of these gases is carbon dioxide. It's a very important so-called greenhouse gas. And what we have in this graph is a representation of the amount of carbon dioxide going back in time. We heard from Mr. Vice President earlier on mention about some recent records that Dr. Keeling was involved with of changes in carbon dioxide in this century. But what we have here going back in time is 160,000 years. And we have levels of carbon dioxide that range between about 190 and 280 parts per million. How do we know this? Well, it turns out that one can measure the composition of air bubbles that are trapped in ice cores, particularly in Antarctica, like as shown here, but also in Greenland. From that, we can really get information about the amount of carbon dioxide, not just locally, but the amount that existed globally at that time. What we have down here, the yellow curve, is a similar record of temperature going back from the present back 160,000 years. And what is very remarkable is, of course, a very large correlation between these two curves. What I'd like to do is to point out where we are now. What we have here are just amounts, you can see in the pre-industrial amounts below 300 parts per million. If we can show the rest of the second panel here, this is to indicate where we are now, which is roughly 365 parts per million of carbon dioxide. And what is striking is this is a level that we haven't seen before, certainly not in these 160,000 years, and that what is also very striking is how fast we're getting there. Let me point out also that besides this very striking correlation between these two curves, there is an important physical mechanism that ties them down, and that's precisely the greenhouse effect. To explain that a little bit more in detail, the way we understand climate often is by doing computer simulations, which sort of synthesize knowledge that we have, because a climate is a very complicated system. These computer simulations are by no means perfect, but we understand, for example, that ice ages come about from changes in the way the energy from the sun reaches the Earth, changes between the way it reaches the poles versus the equator, changes between summer and winter, and that explains, to some extent, the appearance of ice ages. But it's not enough to look at those changes. It turns out that it's important to also consider other effects, such as the greenhouse effects from carbon dioxide, Low levels when the temperatures are low, high levels when the temperatures are much larger. The next question is, where are we heading? And for that, we need to look at one more panel. What happens in the future? That, of course, is a prediction. That depends on what we do. But if we just continue with the so-called business as usual scenario, we can predict that we are going to reach levels way up there, above 700 parts per million. And what is very remarkable is really how fast this would occur on a geological timescale or an evolutionary timescale. It's really like the blink of an eye. I should point out that the Earth has actually seen such high levels of carbon dioxide in the past, but that was some 50 million years ago. And believe me, the Earth was a very different place from what it is now 50 million years ago. So from this sort of evidence, it's what the scientific community really considers this to be a serious problem. Both the magnitude and the pace of change is what makes us really worry and take this problem very seriously.
Thank you very much.
Could you briefly point out the last two ice ages on that temperature record going back into the past?
Yes, the ice ages is, of course, when the temperature is low. We have low temperatures here. This is in degrees centigrade, 6 degrees centigrade, about 8 or 9 degrees Fahrenheit. And the previous one, as the President pointed out, was about 10,000 years ago. I should point out that even though this appears to be just a small temperature change, for example, for people like myself living in Boston, that represents the change between the nice weather that we have today and a whole mile of ice above the surface.
Thank you very much.
Thank you. Now, I'd like to call on Jane Lipchenko, our expert on ecology, and see what such significant changes in greenhouse gas levels might mean for natural resources. Jane?
Mr. President, Mr. Vice President, as both of you are aware, the ecological systems of the world, the forests, the wetlands, the coral reefs, provide the life support systems for all of life on Earth. Most people are aware that we derive goods from these systems: food, fiber, genes, medicines. What most people are unaware of are the services that are provided to us free of charge by these ecological systems of the world. These services include things like the control of floods, the purification of air and water, and even the creation of beautiful places that provide us with recreation and inspiration. These ecosystem services are largely outside our economic systems, but their value is estimated to be well in the trillions of dollars annually. These ecosystem services are provided to us by the functioning of intact ecological systems. And when those systems are disrupted, or when those systems are lost, then we lose the goods and services that are provided by those systems. Climate change will undoubtedly affect the continued provision of these goods and services, although we cannot always predict exactly what the details will be. To provide a few vignettes of the ecological consequences of climate change, in the optimistic scenario of a doubled CO2 world, let me invite you on a brief field trip to different parts of our country. Let's begin in the forests of New England. As the Earth warms and climatic zones move northward or toward the poles, existing forests will be stranded and their processes disrupted. The forests of New England, like probably a third of the forests around the globe, will undergo major changes. For example, we would probably lose sugar maples from the New England forests. Can you imagine going to watch the gorgeous fall foliage in New England without sugar maples? Let's move to the southern parts of our country. Salt marshes in Louisiana are already being submerged. Climatic change would exacerbate this problem as sea level rises between 6 inches and 3 feet. Sea level rise will also affect other coastal ecosystems, for example, the salt marshes and mangroves of the Florida Everglades. A sea level rise of just 1 foot would result in loss of 1/3 of the Florida Everglades. The loss of mangroves and salt marshes would result in the loss of the services provided by these systems. And those services include things such as nursery areas, natural hatcheries for important fish and shellfish, the detoxification of pollutants, the trapping of sediments, the creation of a habitat for unique plants and animals, and protection of shores against the battering of waves. These ecosystem services are vitally important, and when we lose systems, we lose those services. Now let's move to the Midwest. While these highly managed agricultural systems are thought to be quite adaptable, climate change is likely to increase demands on water use to ameliorate soil drying and pesticide use to combat increases in the incidence of pests and diseases. Drought is no stranger to these regions. In the heat wave in 1988, drought resulted in a drop in U.S. agricultural production by 1/3. Flying up to Glacier National Park in Montana, we would be dismayed to find out that fully 73% of the glacial areas has already been lost since 1850 because of climate warming. In fact, climate change is predicted to result in loss of all of the glaciers in the park by the year 2030, well within many of our lifetimes. Even greater ecological changes are predicted to occur in polar regions. As an ecologist, I must emphasize that the slower the rate of change in climate, the less catastrophic the results. Let me repeat that. The slower the rate of climate change, the less catastrophic the results. Species are more likely to be able to migrate, to grow, and evolve if rates of change are slower. At slower rates of warming, more trees could migrate effectively, more corals could keep up with sea level rise, and more species could evolve adaptations. Climate change is only one of many environmental changes that are occurring around the world today. These multiple stresses include familiar things like urbanization, overfishing, pollution, and the loss of biological diversity. Taken together, these stresses are reducing the ecosystem goods and services that we depend upon for our quality of life. As a scientist, I know enough to appreciate how serious and urgent the problem of climate change is. In addition to that, as a mother, I care especially about the prospects of the world that my children will inherit. I do not wish them to have a world that is disrupted and depauperate. The quality of their future depends upon our willingness to act, and to act quickly.
Thank you.
Let me call now on Dr. Steve Schneider to discuss the risks of severe weather events, extreme weather events, which have been predicted to accompany global warming, droughts, floods, hurricanes, and we'd be interested in your thoughts on those and also the interaction of those with rising sea level.
Thank you very much, Mr. Vice President. Mr. President, we're really talking now about the issue of so what if the climate changes. That's what we're addressing at the moment. And this is a question that scientists have spent a long time on. There are quite literally hundreds of studies, some suggesting catastrophic outcomes, some mild. It gets confusing. Economists, of course, want to know how much it costs, what we call climate damage. And in that process of trying to sort through that confusion, a survey was taken a number of years ago by Yale economist William Nordhaus, and included in the surveyed people is Undersecretary of Treasury Summers. I was one of them. And we were asked what kind of damages to the economy might occur from this wide range of impacts. And of course, all the uncertainties we put in, as the Vice President said, scientists cannot avoid that. We observe those uncertainties, but our best guesses, I can summarize briefly for perspective. In a nutshell, the economists in the group gave a number like something like 1% of gross domestic product would be their best guess with lots of uncertainty. And the natural scientists, something in the order of 10%. You might wonder why such a difference. Well, it comes out from the natural scientists having a higher degree of concern over the kinds of ecological services that Jane Lubchenco referred to not being simply replaced. And the economists were more optimistic about human substitution for that. But I don't want to get into who's right or who's wrong. Just put some perspective on it. If we took the lower of those two numbers, remember, 1% of GDP in today's terms for the world is $200 billion. So it's not a trivial question in terms of climate damage. Now, where would a number like that come from? And that's the issue that you asked me. Let's take a look at it in just two examples, the sea level question and the question of hydrologic extremes, by which we mean droughts and floods. Let's do sea level first. We all remember the terrible pictures from Hurricane Andrew. If one costs that, it was something on the order of $40 billion lost in Florida and in other parts around the Caribbean. And physical reasoning says, could we have had something to do with that? I mean, after all, if you increase the temperature of the oceans, that increases evaporation. It might make storms stronger. That debate takes place, but that's very controversial. But one thing we know that isn't controversial is that before 1987, there were no losses larger than $1 billion. And now the insurance industry is very concerned that there are several in the tens of billions of dollars. What else do we know that's not controversial? Sea levels have gone up, as we've heard several times, between about 4 and 10 inches, are projected typically to go up about 6 inches to maybe 3 feet, depending upon how things turn out in the next century. And what we know is whatever the damage that storms do when they go by, whether they're augmented in strength by global warming or they remain natural at the levels that we're used to, they'll be causing flooding from a higher sea level base. As a result of that, the damages would go further inland. And that part is what contributes to that number that was referred to in the other studies. What about the hydrologic extremes? Well, we all saw the pictures of the 1988 drought. We know about the seemingly endless stories of floods now. And the question is, has nature rolled us a double snake eyes, or have we started to load the dice? And that's what the scientific debate is about. And again, there's some well-known physics which says if you increase the heating of something that has water in it, more water will evaporate. Well, that's not, it doesn't require a PhD to figure that out. Almost every farmer knows it, and anybody who's ever tried to water a lawn knows that when it's hotter, the water comes out of the lawn quicker. You have to water more. So what that suggests is more water in the air means when it's going to rain, the rainfall can be more intense. When it's dry, you can have more evaporation. That's where this whole idea comes from. Well, this is out of physics. The question is, what's happening? A line that we have is, often in science is, well, in God we trust, but for the rest of us, please show data. And the data in this case has been coming out quite a lot lately, and Dr. Tom Carl, for example, has been studying, and his colleagues at NOAA in North Carolina have been studying this for a long time, and they've concluded that there's about a 10% increase in precipitation across the United States since 1910. But that's not the interesting part to me, and I want to quote this to make sure I get it correct. The interesting part is, as Tom says, is, quote, the increase in precipitation is reflected primarily in the heavy and extreme daily events, unquote. Translate that, gully washers. The bulk of the rainfall increase has been in those kinds of damaging extreme events. So, is this a natural oddity or is it us? I think we still can't answer that question definitively. All we can say is it's consistent with our understanding, it's consistent with what our computer simulations suggest, but it's still circumstantial evidence. The problem is this experiment is being performed while we speak on a laboratory, but it's laboratory Earth, and we're along for the ride with all the other living creatures on Earth. Finally, we've heard everyone say that this is a very complex system, very difficult to forecast. It's an atmosphere, ocean, land, ice, biosphere system, all coupled. Scientists use the fancy word nonlinear. The IPCC, which referred to several times here, concluded with a paragraph. I know it well as a lead author of the IPCC, and I'll quote what it said in its last paragraph to the summary for policymakers. Quote, when rapidly forced, nonlinear systems are especially subject to unexpected behavior, unquote. Translate that again. In my words, That means reducing the pressures humans put on nature is insurance against potential nasty surprises. Thank you.
You want to ask this question? I want to acknowledge Senator Max Baucus, who I neglected to acknowledge earlier. Glad you were here. Dr. Snyder, before we move on, let me just ask a question that I think has been on the minds of a number of people around our country in the last few years. We had a really unusual flooding event in North Dakota, South Dakota, Minnesota earlier this year. We also had a really unusual flooding event in the Ohio River Valley and in the San Joaquin River Valley and up around Seattle. And a couple of years before that, we had that very unusual flooding event in the Midwest, which created a new shallow Great Lake for a while before it went away. And all around the United States, there are people who are saying to their neighbors, didn't we just have a 100-year flood just a few years ago? And how come we're having another one so quickly? And how does this anecdotal evidence and the tragic experiences of so many Americans relate to what you just said about loading the dice?
I'm trying to resist the temptation to retreat into the usual scientist's caution.
Well, you got an award for not doing that.
Is that what you got that for?
I was about to say, we won't argue. The best that I can say is there's that evidence that you cite. There's also the fact that in the 1990s we had the longest El Nino events in record, which have a major impact on weather all around the world. And there are a whole series of these coincidences, these events which appear to be unusual, any one of which you would argue is just a simple piece of circumstantial luck where nature is being perverse. But a pattern is emerging, and the pattern is consistent with the expectations from our models, and therefore, those combinations of factors are what led the IPCC to make the discernible statement that you said before. So while no one event certainly could be laid to the doorstep of global warming, the increasing frequency and magnitude of these could very well be the first signs that the canary in the cage is starting to quiver.
The canary in the cage is starting to quiver. Thank you very much. Now I'd like to ask Dr. Robert Shope, who studied infectious diseases extensively, to discuss how human health might be affected by climate change.
Thank you, Mr. President. Health and the environment are closely linked. You've heard about the selective warming, especially at night, changes in rainfall patterns, and more frequent storms. If there is a 6-degree Fahrenheit warming, the heat alone in North American cities, such as Washington, D.C., will result in an excess of deaths, especially in elderly people who do not adapt well to severe warmth. We had an example in July of 1995 in Chicago, Illinois. There the temperature exceeded 90 degrees Fahrenheit, both at night and day, during a prolonged period. And there were recorded 465 deaths in Chicago related to the heat. My own personal experience is with diseases transmitted by ticks, mosquitoes, and other biting insects. The agents that cause these diseases are viruses, they're bacteria, and parasites. For the viruses especially, we have no specific treatment. And for the parasites, such as malaria, we have drugs, but these drugs are rapidly, the organism is rapidly overcoming the drugs and becoming resistant to the drugs. Let me talk about dengue virus. This causes a disease in people which is typically a high fever, headache, muscle aches and pains, sometimes a rash. There is a severe form of dengue which we call dengue hemorrhagic fever, which when you have this disease, the case fatality rate or the mortality rate is about 10%. The virus is transmitted by a mosquito that lives in and around homes in tropics, in warm climates, in tropics and subtropics. The mosquito is killed by a hard freeze. Therefore, its northern limit is about Memphis, Tennessee at the present time. We've seen in the last decade a steady increase in the numbers of cases of dengue in tropical America, including Mexico. This disease is now literally on our southern border. In 1995, there were recorded in excess of 4,000 cases in Reynosa and some of the other Mexican cities along the Rio Grande River. I cannot tell you whether dengue epidemics will occur in the United States, and perhaps air conditioning and screened homes may protect us. On the other hand, with climate change and warming, I would predict, and many of us predict, that the mosquito will thrive further north. As the climate warms, the virus will multiply in the mosquito more rapidly. The mosquito will be able to feed more frequently. These same factors apply to the vectors of malaria, also a mosquito. Malaria is a disease that worldwide kills about approximately 2 million people each year. It's a tropical disease. The disease recently has occurred in small outbreaks in the United States, in New Jersey, New York, and also in Texas. With warming, we can expect these epidemics to continue, or small outbreaks to continue and to enlarge. The factors that I've talked about and other factors that we can demonstrate in the laboratory argue for controlling the environment while we still have time. And I would say that the best insurance is preparedness. There are many other such diseases directly affected by rainfall and warming. I'll mention St. Louis encephalitis in the western part of the United States, the tick-borne Lyme disease, which many of you are familiar with, the newly recognized rodent-associated hantavirus pulmonary syndrome, which broke out in 1993 in the southwestern part of the United States. Each nation in the world has its own set of diseases, some of which affect Americans abroad or can be transported and introduced into the United States. Therefore, the problem of climate change and health is of common interest among nations, as are the solutions. Thank you.
So if we get the kind of warming that the scientists are now predicting and a change in climate so that a place like Boston has a climate that we now more nearly associate with Atlanta or even farther south, you would also see a change in the distribution of diseases and the pests and insects that carry diseases. Is that the basic point?
That's the basic point. That's the take-home message, yes.
All right, all right. In the South, we saw kudzu come in. And, you're talking about microbial kudzu, as far as I can tell. I'd like to ask Dr. Henry Kendall, Nobel laureate and chairman of the Union of Concerned Scientists, to speak to the international dimensions of the issue.
Yes, Mr. President, Mr. Vice President, thank you for this opportunity. Disruption of the climate is linked and can aggravate many other human problems. And you've heard some samples today, and they're just samples of a wide spectrum. But one link I'd like to talk to is the connection with world food production. There are developing troubles in this sector independent of the climate, and they're little known. Agriculture, as is widely recognized, needs a stable climate in order to be highly productive. Yet look at 1988. It was one of what appears to be a series of the hottest year on record. But in that year, in the central North American continent, we had a combination of high temperatures and drought. And both Canada and the United States lost 1/3 of their grain supplies. For the United States, it was the first time in 200 years that current production was not adequate to feed us. In the years since, Australia and Mexico have had somewhat similar events. It would be really scary if this becomes a pattern. Now, food demand is expected to double in the next 30 years, which is almost no time at all. Fresh water, which is vital for irrigation, is already short. The human race uses nearly 1/2 of the available fresh water, and 40% of the world's population lives in areas that are water short. Expansion into new arable land is highly constrained, and let me say, the last thing we need are climatic changes and disruption, putting additional pressures on a system which is already becoming considerably stressed. Of course, it's the bottom tier of the developing nations that will get hit directly by shortages. A large number of people, nearly 1 billion, 1 in 6 of everyone living. Many of those nations will have great trouble, and some, I believe, will find it impossible to feed themselves. What this is doing, and it has already started, along with some other factors, is to generate increasing numbers of hungry migrants, environmental refugees, streaming across national borders. Now, these migrants do not wish to be dislocated, and they discover that their destinations don't always welcome them, as the reactions both in Europe, in the wealthy nations there, and in the United States have demonstrated to us. The result is that no nation will be sheltered from dislocation of food supplies, altered trade balances, freshwater difficulties. These are already surfacing in the Middle East, where the United States has vital interests and have engendered more than 6 wars out there. Flow of migrants, which may at worst increase into the hundreds of millions of people. And even though the wealthy nations will remain able to feed themselves and remain well-fed into the future, no nation will escape the troubles from pressures on the food supply. Mr. President, it is not the case that one end of a boat can sink. So let me say that this is a developing problem in national security, and we have to deal with it. The best way to deal with problems of that sort is to stop them at the outset and not wait until the results are presented to us and the great troubles develop. Thank you.
Thank you. Let me ask you something. Even if, and I don't really want to take you afield from the subject, but one of the things that has perplexed me about this is, won't there be serious problems of water quantity and quality almost no matter what we do?
Well, there will certainly be developing problems, and I think it is slated to get worse, but we have it under control at some level to keep them from getting extraordinarily harsh and severe. Disruption of the ecosystems does interrupt the purification of water in wetlands, and as these disappear, as they're doing here, it will hurt water quality. If there are shifts in patterns of rainfall, it will upset ecosystems, it will upset agriculture, and this will certainly develop because some of the greenhouse warming is now at some level irreversible. The hope is to keep it from developing to unacceptable levels of severity.
Thank you. I'd like to now turn to Dr. John Holden, who's worked on many global issues: energy, the arms race, plutonium disposition. He's done a lot of work for us on that and I thank him for that. I'd like to say that to go back to my opening remarks, you signed the scientist statement. You clearly see this as a big threat. Many people here and around the world seem unconcerned. Why do you think people are underrating the importance of the issue, and what do you think we can do about it? And secondly, one of the things all the developing countries are saying is, well, right now, you rich countries are the biggest part of the problem, and when you want to include us in this, you're basically just trying to keep us poor. So let us pollute a while and get rich, and then lecture us about fixing the environment. What is the responsible way for the wealthier countries to do what we should do and still get the developing countries to do what they can do within the context of their legitimate aspirations for their people? I think this is I know I'm asking you a political question here, but you must have thought about it in the context of what you're trying to achieve.
Well, Mr. President, given the second part of that question, I assume my time has been doubled. But,
I've noticed you speak fast when you're excited about something.
I'll try to do that. I think, Mr. President, Mr. Vice President, there are at least 6 reasons why most people underrate the seriousness of the climate disruption problem. And running through those 6 reasons gives us a way to revisit, in a way, many of the most important points that were made this afternoon, and I'll end up right at the second part of your question. I think the first reason that people tend to underrate this problem is that human well-being is a lot more dependent on climate than most people think. As you've heard today, we're talking about the productivity of farms and forests and fisheries. We're talking about the frequency and intensity of floods and droughts and heat waves. We're talking about the geographic pattern of disease. We're talking about sea level rise and associated destruction of coastal property. And we're talking about the potential for political tension and conflict over these consequences, and out of disputes over who's responsible and who should pay, which is part of the last problem you were mentioning. Second reason people tend to underrate this problem is that climate disruption is a lot further along than most people think. As we've seen, atmospheric carbon dioxide is already higher than it's been in the last 160,000 years. The global surface temperature, which is expected to lag behind increasing carbon dioxide concentration, is higher than it's been in the last 1,000 years. And the evidence of this, the indicators of this climate change, are apparent in rising sea level, in increasing precipitation, in changing patterns of disease, and in a lot more. The third reason that many people are more complacent than they should be is that the climate implications of future growth in population and future growth in energy consumption are a lot bigger than most people think. We're going to have, in the year 2050, barring near disaster, something like 9 billion people compared to less than 6 billion today. We're going to have energy use under business as usual that will be 3 times higher than today's worldwide. We're going to have carbon dioxide emissions that are 2 to 2.5 times today's worldwide. And remember that today's are already in the process of getting us into serious climatic difficulty. We're going to be, in the year 2050, if we don't change business as usual, a long way down the path toward a climate regime that hasn't been seen on this planet in 50 million years. Fourth point is that scientific uncertainties are not grounds for complacency, in spite of what many people think about that. There are uncertainties about many of the details of timing and magnitude and regional variation in the consequences of climate change. But there is no uncertainty at all that humans have altered significantly the global atmospheric concentrations of gases we know to be critical in controlling climate. And there's a solid consensus among the scientists who have studied these matters seriously that the chances of significant impacts on human well-being from climate change over the next few decades are substantial. You also need to remember that uncertainties, such as they are, cut in both directions. It could turn out that disruption to human well-being from climate change is coming at us more slowly and in smaller magnitudes than today's best estimates predict. But it also could turn out that those disruptions are coming at us faster and in bigger magnitudes than today's best estimates predict. And indeed, in looking at what most of the computer simulations of the consequences of climate change leave out, I personally would bet on worse than the best estimates rather than better. Fifth reason that people underrate the problem is that the time lags between cause and effect and between effect and remedy are longer than most people think. Those time lags, and above all, the several decades that it will take to substantially transform the world's fossil fuel-dependent energy supply system, mean that doing nothing is a very dangerous course of action. The world's energy economic system is a lot like a supertanker, very hard to steer and very bad brakes. Now, we know from the science that has been reviewed here today that that supertanker is heading for a reef, and we can see the water under the hull getting shallower and shallower as we go along. Now, even though we can't say exactly when we're going to get to the point that that reef rips the bottom out of the supertanker, it's a bad idea in these circumstances to keep on a course of full speed ahead. In fact, in this situation, pointing to uncertainties about the details, pointing to areas of ignorance and saying, well, it's fine, is like saying, since this whole supertanker business is proceeding in the fog, we should feel better about it. The last reason that I'll mention here that people tend to underrate this problem, gets to the second part of your question, is that the fate of industrialized and less developed countries is a lot more interconnected than most people think. Now, it is true that the industrial nations like the United States, because of their wealth of capital and technology and infrastructure, are in a better position than the less developed countries to change and adapt and adjust. We'll still suffer from climate change, but the developing countries will probably suffer more. Should that make us happy? Should that make us complacent? Certainly not. We all live on this planet under one atmosphere. We all live on the shores of one global ocean. Our countries are linked by flows of people, of money, of goods, of ideas, of images, of drugs, of weapons. It should be clear, as Dr. Kendall already said, you can't have one end of the boat sinking while the other end floats. If we are to enjoy, in the industrialized countries, a stable and sustainable prosperity, we are only going to be able to manage that if we can achieve for the rest of the world now less fortunate a stable and sustainable prosperity as well. And the only way to do that is going to include addressing the danger of global climate disruption in a cooperative way. That cooperation in everybody's mutual interest is the key to the second part of your question. And I really want to say, Mr. President and Mr. Vice President, all of us applaud your initiative and your leadership in stepping up to the challenge that this global problem and the need for global cooperation to address it represents. Thank you.
Thank you.
I have one brief question. There are some people who say, why don't we just wait a little while longer before we take any action? This year, incidentally, marks the 40th anniversary of the first measurements of CO2 in the atmosphere by Charles David Keeling and the late Roger Revelle. And in that 40 years, we've seen all this science emerge. Some people ask, why not wait a little bit longer before taking any action? What's your response to that?
Well, my response to that is, above all, that this supertanker is hard to steer and it's hard to stop, and every additional year, every additional decade that we keep on with business as usual, that we keep on building additional energy systems that are, as today's are, 3/4 dependent on fossil fuels without control of their greenhouse gas emissions, the more difficult it's going to be to change that path. The supertanker is gaining momentum. It's getting harder to steer every year that we fail to do anything about it. So we are committing ourselves more and more to higher and higher atmospheric concentrations, larger and larger degrees of climatic disruption with every year that we delay. That's a bad idea.
Thank you.
Thank you very much. Let me again, thank you all for your patience and your interest, and I think we should give our panelists of scientists another hand. I wish every American could hear what we've heard today, but thanks to our friends in the media, a good number of them will hear at least a portion of what we have heard today, and this is the beginning of a consistent long-term effort that we all have to make to involve the people of this country in this decision. And I thank you all for the points you made, because in different ways each of them will resonate with the citizens of this country in a way that I believe will give us the support we need to take the action that has to be taken. In the weeks and months ahead, the Vice President, the Cabinet, other members of the administration, and I will be out in the country discussing this. We'll be working with the American people. We'll be talking about solutions as well as problems. The truth is, it's like anything else, that the quicker you get, another answer Dr. Holden might have given is that the quicker you get after this, the less extreme the remedy you have to embrace to have a measurable effect to avoid an undesirable outcome. And the longer you wait, the more disruptive the ultimate resolution will be. So that's another thing that I'd like to emphasize. Before we close, I hope you will permit me to make a brief statement. Just before I came in here to this meeting, I learned that today, and not very long ago, retired Supreme Court Justice William Brennan passed away. He was a remarkable human being, one of the finest and most influential jurists in our nation's history. He served on the Supreme Court for 34 years. He was, perhaps during that period, the staunchest, most effective defender of individual freedom against government intrusion. His devotion to the Bill of Rights inspired millions of Americans and countless young law students, including myself. And one of the great honors I have had as president was to be able to award him the Presidential Medal of Freedom in my first year in office. He once said, "The role of the Constitution is the protection of the dignity of every human being and the recognition that every individual has fundamental rights which government cannot deny." He spent a lifetime upholding those rights, and he authored some of the most enduring constitutional decisions of this century, including Baker v. Carr on one person, one vote, the New York Times v. Sullivan, which brought the free speech doctrine into the latter half of the 20th century. The force of his ideas, the strength of his leadership, and his character have safeguarded freedom and widened the circle of quality for every single one of us. We will miss him greatly, and I know you join me in sending our best wishes and our prayers to his family and friends and our gratitude for his life. Thank you very much.